Hello, I'm Mrs. Neill, and this is geometry lesson number 15, Proving Triangles Are Similar. Today, we're going to go over 3 similarity rules. Angle-angle similarity, and I'm going to give you 3 examples of that one. Side-side-side similarity, and I'll give you 1 example of this rule. Side-angle-side similarity, and I will give you 2 examples of this one. So in all, we're going to look at 6 different triangle similarities. First of all, always remember this. Similar figures have the same shape, but not necessarily the same size. So we're not proving triangles are congruent like we did a couple of chapters ago. We're proving that they're similar. And our figures that we'll be looking at today will be triangles. And you're going to have one triangle that's going to be big, and then one triangle that's going to be smaller. So let's start with our very first rule, which is angle-angle similarity. And here's our first example. The first example I have is where the triangles are separated. They're not connecting or touching each other in any way. So our rule is, if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. So we need to prove that 2 angles are congruent to each other. And this is a very direct example. You can already see that angle B is congruent to angle Y. It's got the 1 arc mark there. And angle C is congruent to angle Z. So we've already got our AA. We've already got our 2 angles. Therefore, we can say that triangle ABC is similar to triangle XYZ. All right, let's look at our second example. We're still looking at AA, but we're going to do the second example now. So if you need to stop the video to draw the picture or give yourself a little more time, please do that. So example 2, here's the postulate. I just rewrote it again from what we did in example 1. But in this case, we've got alternate interior angles that are congruent and vertical angles that are congruent. If you notice, you've got a big triangle and a smaller one over here, but they're joined. They're joined right here at point C. Now look at the bow tie. Remember when you see a bow tie, what angles do you have? I have vertical angles. So I could say that this angle ACB right here, that gives me 1 angle, is congruent to the angle YCX. So that would give me 1 angle out of our angle-angle similarity. So now let's look at alternate interior angles. Now I'm going back a couple of chapters. Remember, alternate interior angles are congruent. And I have an example, and I'm going to place this right on top of my diagram. If you notice, I have 2 parallel lines, and they're cut by a transversal. These 2 angles, Y and A, are alternate interior. Let me take it up and show you what it looks like here. I've got 2 parallel lines. The transversal's cutting right here. So angle A, right here, I'm going to put 2 arc marks. And angle Y, those are alternate interior angles. Let me put this diagram back on here, and you might want to do this yourself. Just draw through a piece of paper there. Okay, A and Y are alternate interior, so those 2 angles are congruent. So I've already got my AA right here. I've got this one and that one. These 2 make 2 angles. However, I have another set of alternate interior angles. I want to show you all of them. If we go the other way, if I have 2 parallel lines here and my transversal is cutting this way, what about B and X? Okay, so I'm going to get my paper on top right here. See right there, I have my 2 parallel lines. Here's the transversal here, and then B and X are alternate interior angles. So that's actually another set of alternate interior angles. And I'm going to mark those with 3 arc marks. So now B and X are congruent, and A and Y are congruent. Actually, we found 3 angles. For angle-angle similarity, we only need 2, but we happen to have found 3. So just pick the 2 that you want to have as congruent. Then you can say that triangle ABC is similar to triangle YXC. Let's look at our third example of AA similarity. Okay, this is an example where you have one small angle. Well, actually you have one big angle and then you have a smaller angle on top of it. So if you notice, you have small triangle AXY right there, and you have big triangle ABC right there. So if you notice, they're going to have some angles that are congruent with each other. Which angle that is, you can easily see that's congruent? If you notice, A is congruent to itself right there. And that's the reflexive property. But we also have some corresponding angles, because see, this is marked, that little arrow right there. That means that these 2 sides are going to be parallel. And then if you have a transversal cutting through it, you can have some corresponding angles congruent. So let me get out my little paper on top, and I redrew it right here. See right there where I drew angle X and angle B? Those are corresponding angles. Remember those from a couple of chapters ago? Let me lift up my paper. So X and B are congruent, and let me name, I'll put 2 arc marks for those. So X and B are congruent because they're corresponding. Well, actually, I've already got my 2 angles. I have an angle A congruent to itself, and then these 2. But let me show you the third one. If you go on the other side, I've got 2 parallel lines cut by transversal. How about Y and C? So let me get my see-through paper. Put that right there. Notice I've got 2 parallel lines cut by transversal. So C and Y are corresponding angles. See how that works? Y and C right there. Those are going to be corresponding angles. So those angles are actually congruent to each other also. And I'm going to put 3 arc marks on that one right there. So as a result, Y and C are congruent. Now with AA, you only need 2 angles. So pick which 2 you want to be congruent to prove. Then you can say that triangle AXY is similar to triangle ABC. All right, that's our first AA similarity rule. Second one is side-side-side similarity, and I only have 1 example for that one. Okay, if you need to, stop the video so that you can draw the figure and write down the theorem. The theorem says if all 3 pairs of corresponding sides of 2 triangles are proportional, then the triangles are similar. So what we need to look for is set up a proportion and look for a similarity ratio. So I've got triangle ABC and XYZ right here. And I'm going to look at all the corresponding sides and see if they have the same similarity ratio. Remember, we talked about that a couple of days ago. So you have to set up your ratio the same way for each side. And if you notice, I have big over small. What I'm going to do is I'm going to use the side on the big triangle on top, right here, AB, for example, there, over the small triangle. So this side on the small triangle, which is 6, goes on the bottom. So I'm going big side over small side. Big triangle over small triangle. So 9 over 6, remember to reduce every fraction that you see, and that gives me 3 over 2. So now I've got to come over here and look at corresponding sides and see if they're proportional over here now. And I'm going to go big over small. You have to do the same order each time, which is 12 over 8. Reduce it and get 3 halves. Now we're doing the last one. I have to do all 3 of the sides, all 3 pairs. 15 over 10, reduce it, and you get 3 halves. So you have to get a similarity ratio of 3 over 2 for each one of these. If you don't get 3 over 2 here or here, they don't all match, no, those two triangles are not similar. But since this works in this case, I can then say that triangle ABC is similar to triangle XYZ because of SSS similarity. Okay, let's go down to our third similarity rule, which is side, angle, side. So what that is, that's going to be a side, an included angle, and a side. Remember that? So if I have a triangle here, if I have a side and I have a side, what is the included angle? It has to be right in between there. So it's going to be this angle right here. So that's going to be my angle. So it's got to be side, included angle, and then another side. So that's what we mean by side, angle, side. Kind of like when we did side, angle, side with congruent triangles a couple of chapters ago. With this one, I've got two examples. So here's example 1, and here's the theorem. So if you need to stop the video and write this down, please do. So for side, angle, side similarity, if two pairs of corresponding sides of two triangles are proportional, they don't have to be the same length, they have to be proportional, and the included angles are congruent, then the triangles are similar. So here's an example. There's two examples that I'm going to give you. Here's the first one, and it's where I have separate triangles. The triangles are not touching or connected to each other in any way. If you notice, I have a small right triangle, and then I have a larger right triangle. This tells me it's a right triangle because of that little square there. So I know that angle B is congruent to angle Y. So now I've got to check my two sides. I've already got the angle that's congruent. Now I've got to check the proportionality of that side, and then this side and that side. So now, are the sides proportional? Let's find a similarity ratio. I'm going to take small triangle over big. Okay, it doesn't matter if you go big over small or small over big. Make sure you set it up the same way every time. That's very important. So I'm going to take AB, which is 10, over XY, which is 16. Don't forget to reduce it and get 5/8. Now, I want to go and do the next one, which is BC over YZ. So BC is 15, YZ is 24. Don't forget to reduce it, and I got 5/8. If you notice, I have the same similarity ratio each time. So I've got an angle and two sides. So that's going to be SAS similarity. So as a result, triangle ABC is similar to triangle XYZ. All right, our very last example for the lesson is still looking at side, angle, side, and we're going to do example 2. What I did here is I just wrote down the theorem again. This is what you saw just a minute ago with example 1. But this example, I've got a small triangle on top of a big triangle. We looked at one like this just a little while ago, where I have a big triangle, and then I have a smaller triangle on top of it. So they're going to share some things. So what I did is I divided the triangle, split them up. And here's the small one, AXY. This side is 20, and this side 16. Now, please notice, here's my big triangle, ABC. What is the length of this side? It is not 25. 25 is from X to B. From A to X is 20. From X to B is 25. So what's the length of AB? 45. 20 plus 25 is 45. Do not write 25 there. You will get the problem wrong. Okay, let's look right here. AY is 16 right here. And then YC is 20. So what is AC? It's going to be 16 plus 20, which is 36. So that's probably one of the hardest things to remember on this kind of triangle, is to make sure you get the sides the right length. All right, I need a side, an angle, and a side. Let's look at the angle. If you notice right here, angle A is congruent to itself. So right there, I've got the A part of that. Now, are the sides proportional? I'm going to go small triangle over big triangle. So I'm going to start over here on this side, and I'm going to go AX, which is 20, over AB, which is 45. Don't forget to reduce it, and my fraction is 4/9. So my ratio, similarity ratio, is 4/9 right there. Now let's go to the other side. I've got AY is 16, and then AC is 36. Don't forget, you can reduce that by 4, and you get a similarity ratio of 4/9. So those are the exact same ratio value. So now I've got the two sides. I've got the two sides and the included angle right there. So now I can say that triangle AXY is similar to triangle ABC. That is our lesson for today. I'm Mrs. Neill. Thank you for listening.